So today we're going to talk about exponential growth and decay, which we've done before in Math 1, so we're just looking at it again just to refresh our memories. A function with the general form y equals ab to the x, where x is a real number, a is not equal to a is not equal to 0, b is greater than 0, and b not equal to 1. Remember that a is your initial value and b is the growth or decay factor. So if the equation has a b value that's greater than 1, we know it's growth. If the equation has a b value in between 0 and 1, we know it's a decay factor. So think of fractions. So looking at this first graph, we've graphed this quite a few times before. So we know y equals ab to the x power. In this case, if the a is not written, it's just equal to 1. B is the part with the exponent, so that's 2. And so we know because b is greater than 1, this is growth. And so if we plug in our values to the -3, we know is 1 over 2 to the third, which is actually equal to 1/8. 2 to the -2 is equal to 1 over 2 squared, which is 4. So 1/4. 2 to the -1 is equal to 1/2. 2 to the 0 power is equal to 1. 2 to the 1, 2, and 2 to the third gives us 2, 4, and 8. And so go ahead and plot that. So when we plot our points, we can see this is exponential growth because as you move along your graph, going from left to right, least to greatest, you notice that your y values are growing. And of course, we've also talked about the fact that there is an asymptote on our graph here at y is equal to 0, so it's a horizontal asymptote. All right, looking at the next one, we have y equals 10 times 0.5 to the x. So for this one, a is equal to 10, b is equal to 0.5, so we know this is going to be exponential decay. And for this, you can use your calculator if it helps you to plug in these values to get the y values. So when you do so, you should get 80, 40, 20, 10, 5, 2.5, and 1.25. Be careful how you plug these into your calculator. A lot of times I see students try to do 10 times 0.5 and then to the x power. You cannot do that because remember you have to use PEMDAS. So you have to do 10 times 0.5 to the -3 power using those parentheses. So go ahead and plot these points. So when you plot your points and graph, you'll notice that it is exponential decay because as you move from left to right on your graph, your y values are decreasing. And we also still have our horizontal asymptote at y equals 0. And the domain for this, just like the other graph, is all real numbers for exponential functions. We've talked about that already. And the range, just like the graph above, is from 0 to infinity. Something else we can go ahead and look at. So what would be the rate at which we are growing for this first graph? Well, remember that's your b value. So if you want to find the rate, you need to find the percentage. So we've talked about in Math 1 that remember b is equal to 1 plus r, so 1 plus your rate. So if b is 2, then what's r? So subtract the 1, and you get r is equal to 1. And remember, you want to write this as a percentage, which means you need to multiply this by 100. So 1 times 100 is 100, so that means r is equal to 100%. So the rate at which we're growing is 100% when we have a growth factor of 2. So keep in mind that the growth factor is not telling you the rate, so be careful with that. So looking at number 2, your B value was 0.5, so the rate at which we are decaying, use this formula still. So if you subtract the 1, you get negative 0.5 is equal to R. So multiply that by 100. So that's negative 50% is equal to the rate. So that means you're decaying by 50% each time for this graph here. And so that, what we just talked about, it says if you know the rate of increase slash decrease R, you can find the growth or decay factor by using the formula B is equal to 1 plus R. We just did the opposite. We knew the growth slash decay factor and we found the rate. So for the annual rate of change, find the corresponding growth or decay factor. So for this first one, 25%, first of all, we want to find what the R value is by dividing that by 100. So that means R is equal to 0.25. So then your B value is equal to 1 plus R. So B is equal to 1 plus 0.25. So B is equal to 1.25, which is a growth factor. So that's what we would use in the equation, not the percentage. Looking at B here, so same thing, divide that by 100, and we get R is equal to negative 0.15. So B is equal to 1 plus R, so 1 minus 0.15, which means B is equal to 0.85, which means this is a decay factor, which makes sense because it's negative 15%, so it should be something in between 0 and 1. For the next one, divide that by 100, and so R is equal to 3. So B is equal to 1 plus 3, so that means B is equal to 4 for the growth factor. So notice that for something to grow by 300%, your growth factor is 4. For the next one, it says the population of the United States in 2000 was about 281 million with an average annual rate of increase of 1.24%. Find the growth factor for that year. So if R equals 1.24%, divide that by 100, which gives us an R value equal to 0.0124. So B is equal to 1 plus R, so B equals 1 plus 0.0124, so 1.0124, which is your growth factor. And for B, suppose the rate of growth continued to be 1.24%. Write an exponential function to model the US population. So exponential model we know is y equals AB to the power of x. So A is your starting value, B is your growth or decay factor, which we just found, and X and Y are just the variables. So Y is equal to, what is our starting amount? It told us 281 million. So if it gives you like this, you don't have to put all the zeros in, you can just leave it like that in your equation, and just make sure to label your answers when you're done with the correct units, millions. So 1.0124 to the power of x would be our equation, because again A was equal to 281 million. Looking at C, it says estimate the population in the year 2015. So for this one, if you go back to the problem, remember it says in 2000 it was about this much. So here 2015 minus 2000 is what we are using for our x value, which is 15 years. So in my equation, y equals 281 times 1.0124 to the power of 15. And then if you plug that into your calculator, you get y is equal to 338.05 million people. And normally when you're talking about people, you don't leave decimals, but again, this is in millions, so we know that the decimal would be moving to the right, so we wouldn't actually have part of a person. All right, so for the next one, it says writing exponential functions. Write an exponential function form of y equals ab to the x power for a graph that includes these 2 points here. So for this, if I want to use my calculator to plug these in, that would be the easiest. So we're looking for y equals ab to the power of x. So if I go to my calculator, I'm going to go to stat, turn it on first, and then go to stat, and hit enter on edit. And list 1 is going to be your x values, and list 2 is going to be your y values. So for my x values, I had 2 and 3, and for my y values, I have 2 and, sorry, yeah, 2 and 4. And then I can go to stats, right arrow to calculate, and if I go down, you'll notice it says EXPREG, which is exponential regression. Enter. We're in list 1 and list 2. Don't worry about this or this for now. We can just go ahead and hit calculate. And when I do that, I get my equation A is 0.5 and B is 2. So that means we have y equals 0.5 times 2 to the power of x. So there's the steps. Why don't you go ahead and do 6 on your own, pause the video. When you're done, you can unpause it to check your work. All right, so if we look at this one, we go to our stat and then enter on edit, we have our stuff from our old list in there. So to clear it out, you can do one of two things. So this was just to put it back in 4. So I can clear it out by going up to the list and hitting clear and push down. Don't hit delete, because if you hit delete, notice it deletes the actual list, which you don't want to do, and then you would have to insert it back in. So just hit clear and down. Or if you're not highlighted at the top of the list, you can also hit delete on the actual number. So either of those two ways work. So we know that the x values are going to go into list 1 and the y values go into list 2. And then stat, right arrow to calculate. We're going to do 0 for exponential regression and then enter all the way down to calculate. And so there is our A and our B values, and we can go ahead and write our equation. Y equals 0.25 times 4 to the power of x. Now, if you have an older calculator, your screen may look slightly different when you're doing the calculations, but it'll be similar to what we just did. All right. Analyzing functions. Without graphing, determine whether the following functions represent exponential growth or decay, then find the growth or decay factor. What is the rate at which the graph is growing or is decaying? So looking at this first one, we know that b is equal to 5, which is a growth factor. And so if we want to find the rate, remember that b equals 1 plus r. So in this case, 5 equals 1 plus r minus that 1, so 4 is equal to r. And of course, we need to take that and multiply it by 100. So the rate is equal to 400%. So go ahead and do the other 3 problems. When you're done, you can unpause the video to check your work. So for question 9, b is equal to 0.95, and that's s should not be there, it's just to the power of x, that was just an accident. So that means this is a decay factor, and then the rate at which we are decaying, b is equal to 1 plus r, so 0.95 equals 1 plus r, subtract 1, and we get negative 0.05 is equal to r. Multiply that by 100, and our rate is equal to negative 5%. Looking at question 10, b is equal to 5/4, which is as a decimal 1.25, so that shows you that's growth. So it's growth factor. Then the rate at which we are growing, b is equal to, again, 1 plus r. So if you want to use a decimal, that's fine. So 1.25 is equal to 1 plus r, subtract the 1. 0.25 is equal to r, so multiply that by 100, and r is equal to 25%. And over here, b is equal to 1/2, so that means this is a decay factor. And 1/2 is equal to 1 plus r, subtract the 1. So that means that 0.5 is equal to r. So r is equal to 50% negative, sorry, negative, not positive, negative 50%, because again, it's a decay factor, so we know we're decreasing. All right, depreciation is a decline in something's value from age and wear. When an item loses about the same percent of its value each year, you can use an exponential function to model its depreciation. So the deer population increases at a rate of 3% per year. There are 300 deer in your area. Write a function that models the deer population in your area. How many deer will there be after 10 years? So y equals ab to the power of x. A is the starting amount, which is 300 deer. And so then r, they told us, because again, it's a percentage, so we know that's not the growth rate or decay rate. So we know it's going to be a growth rate though, because it said increases. So for this one, that's 3%. So first we need to make that into decimals, divide that by 100. That gives us 0.03. So b equals 1 plus r, because we have to find b for the equation. We don't use our r value. We just use the r value to find the b. So b is equal to 1 plus 0.03, which is 1.03. So y is equal to 300 times 1.03 to the power of x. That's the first part. That's the function. And then how many deer will there be after 10 years? So when x is equal to 10, y is equal to 300 times 1.03 to the power of 10. So when you plug that into your calculators, you get about 403.17. We don't have part of a deer, so 403 deer. Go ahead and do 13 on your own, and when you're done, unpause the video to check your work. So for this one, it says a new iPhone that sells for $600 depreciates by 20% each year. Write a function that models this, and then what's the value after 10 years? So y equals ab to the power of x. A is equal to 600. B is equal to 20%. B, sorry, R, not B, it's R. It's percent, your rate. So divide that by 100, and that is equal to 0.20. So b is equal to 1 plus r. So b equals, and we're depreciating, so I didn't put the negative in there. I need to put that negative there. Sorry about that. So 1 plus negative 0.20. So that gives us b is equal to 1 minus that is 0.8. So y equals 600 times 0.8 to the power of x. And if you didn't get something between 0 and 1 here, then you would want to look at it again, because again, we know we're depreciating because that's what it told us in the problem. So for the next part, when x is equal to 10, y is equal to, when you plug this into your calculator, $64.42. So that would be the value of the phone after 10 years. And that's it for this lesson.